Hello and welcome to session 7 of the MMO development class. My name is Nelson LeKay, and today we're going to be writing some code. So the goal for today is to actually go about creating our game, at least as far as the user interface is concerned. The way I want to approach this, and the way that I typically do approach all networking programming or game projects that I have worked on in the past, is that I like developing everything outside and isolated from concerns of networking. So as long as you architect your classes properly, it should be fairly straightforward to test your game without a network connection, and then tie it into your networking code later. So I don't know how long this process is going to take. We might be able to get wrapped up today. It might bleed into next week. But once we get the game actually running locally, at that point we'll tie in the stuff that we've been working on before. And at that point, we'll have a pretty much a working game, so we can start looking at moving into something like CGS or the serialization. So also, I do want to give a quick disclaimer. I haven't particularly worked with this style of Unity development for a little while. So if I get some of my math wrong, don't hate me. We'll figure this out together. So what I'm first going to do is I'm going to create another scene. We have our scene 1. I'll rename that to something meaningful later, but for now I'm going to go ahead and create another scene. Actually, I'm going to create a folder under my scenes folder called tests. I like just calling these tests. And then I'm going to create a scene under that. If I can remember how to create a scene, there we go. Create a scene under that, and let's call this game test. So under game test, what we're going to need is another sort of game object, a game manager, that will instantiate our game view and then just kind of simulate it being plugged into a network infrastructure. So under code, I'm going to create another folder. I'll figure out a better way to call test. I'll re-architect that, refactor this organization later, because it's kind of getting ugly. But for now, let's go ahead and create tests, and I'm going to create a game test manager. And then I'm going to attach my game test manager to an empty game object, or to the camera, whichever one. Move down there. Can't just remember what I decided to do last time. Yeah, I put it on the camera, because I'm lazy. Okay, so let's jump back into the other scene. No. Go to game test. And let's go ahead and add my game test manager to the camera. And we now have a game test manager. Well, these are tests. I call them tests because they're just a way to simulate a particular use case so that we can exercise some code. However, they won't be automated. Although I do want to get into some automated testing for our library components as well as our game logic components on the server. Unit testing user interfaces, yeah, that's not fun at all. Okay, so I'm going to go ahead and fire up my game test manager, which I thought I already had that thing open in the thing. Maybe I don't have it open in the thing. So, which means it's going to take a second for it to open in the thing. Okay. So we have our game test manager, and what's he going to do? Well, he is going to basically interact with other components. He's basically going to instantiate a game object that is going to be responsible for building our game. So let's do that. The first thing I want to do is, just because we will be instantiating quite a few game objects, I'm going to create a little helper. I'm going to create a game object factory. It's going to be a static class, and it's going to have a public t component create t component where T component is of type component, found under Unity Engine. And then what he's going to do, of course, he needs to be static. What he's going to do is he's going to create a game object. And I actually want to accept a name, so I'm going to go ahead and add a parameter called name to this method, and then game object is going to have add component of type T component, and then it's going to return the result of that. So we're not actually technically creating a game object. Technically, we're adding a component and then returning it, but we're creating a game object in the process. Next up, I'll create an overload, or I'll just use a default argument. There we go. So that we don't have to specify a name if we do not want to. Although specifying names does make your inspecting a lot easier. So now that the game test manager, we now need to go ahead and create the game object or the mono behavior that's going to be responsible for handling our game. I don't necessarily want that to be a, well, we can make it a game object. Why not? For now, I'm going to leave everything under the code namespace, and the reason I'm doing that is I really do want to organize it a little bit better, but I want to wait until I have more classes in place to decide on the organization scheme. And being that I'm in Visual Studio 3 Sharp, altering that sort of stuff down the road is very easy to do. So I'm going to create a class called GameBoard, and he is going to be oh, that's a good point. I totally forgot. See, I thought that it does use a C#4 compiler, but it's running on the .NET 2 runtime. So let me see if this even compiles. And I'm not getting any errors, so I'm assuming it's compiling. Well, 3.5 isn't the runtime. .NET 3.5 was C# version 3 and CLR version 2. So that's why, however, if you can still compile with the C# version 4 compiler, but target CLR 2, which means you'll still be able to do things that are only in C# 4, but that can compile into code that could be understood by the CLR2. That's why if you use a C# 3 or C# 4 compiler, you can still use lambdas and have it still target this .NET 2 runtime. Yeah, no, it's confusing. And then they did the whole .NET 4 thing, which introduced a new runtime, a new version of C# and a new version of .NET. Then they did a .NET 4.5, which is technically an in-place update, which is, I believe, still using the .NET 4 runtime, or it overwrites it to the .NET 4.5 runtime. It does something dumb. And then .NET 4.5 uses C# 5. So if that wasn't confusing enough for you guys, I don't know what is. Alright, so we have GameBoard, it's mono behavior. So what I want to do is I want to instantiate it, and then I want to add some runes to it and pretend that I'm playing a game, essentially. So like I typically like doing, I'm going to write some code against this component without actually implementing those methods yet, just to see how I can make the interface look. So I'm going to say var game equals game object factory dot create GameBoard. And so what do we need to specify for a game? Well, we can start off with specifying player names, because I want to display the player names on the game board itself. Then we need to specify the, let's think, the width of the game board, or how many tiles it is. And then we need to specify the tiles that are actually going to go in the game board. And then we need to specify the available runes that are in the game board. So that's our job. So let's see what we can do. We can go ahead and say game. First thing we should tell it about are the sessions. Now what I could do is I could have a .NET 4. So Unity uses the .NET 4 runtime. because I tried using the dynamic functionality before and had some issues with it. The compilation errors that I was getting wasn't from the compiler not knowing what dynamic was. It was from the runtime not having the libraries that are required for the dynamic code to run. So I know it's using a .NET or a C#4 compiler, but I'm pretty sure the runtime is still in .NET 2 or CLR version 2. Okay, so is this a Skype message or response to my comment? Response to your comment? Oh, talking about .NET 4.5 still using the 4 runtime. Okay. I can't remember. I read the release notes, but it was a while ago. I can't remember. They did something weird with an in-place update. So I don't know if the version numbers changed. I can't remember if they did or not. Anyway, so what do we need to do? We need to tell it about who's playing the game, and we need to tell it about the... So let's start off with something like start game. It seems like a sensible thing to do. And what does start game need? Well, we need to pass it in some sort of representation of a player. Now, we know that players are going to have unique IDs because we're going to need to be able to keep track of who is who. So I can start off with creating a class, or I can reuse one of the classes that I've already created, because I do believe that this is not the project I wanted, and I don't even know why it's open. Go away. I do believe that that isn't either. I do believe that I do have a value object called lobby session, but it's called lobby session, so I don't want to reuse it. Let's start off with creating some classes in the Unity project and then move them into the server as appropriate. So let's create a game session class, which is going to have a string username and a uint user ID. And I want to pass in an array of instantiated game objects, or game sessions, because our start game method will need to know who's playing the game. So let's do player 1 with the user ID of 1, and let's do player 2 with the user ID of 2. Next up, we need to know which one of these players is us. So what I can do is maybe I can take player 1, turn him into a variable, or alias amount to a variable called rSession, and then pass in rSession as another parameter or as another argument to the start game method. So that seems sensible. The game now knows who's playing the game and who the current player is, which is something that the game is going to need to know. Or maybe not, but we'll see. Okay, so we have start game. We now need to, or I could change this to init players, and then I can now go through and add in the runes. So if you guys recall from the actual game design of what we're looking at, the goal of this game is going to have two gutters on the left and right hand side of the screen that have runes in them, just little tiles. And then in the center we have a game board which has slots, and you have to match up the tiles with the slots, and whoever matches up the most tiles in the shortest amount of time wins. So we first need to tell the game about the slots that we want, and we also need to tell the game about the size of the game board, or how many columns there are. So we can do that by saying game dot, let's see, can we pass in a, well, or I could just do something like var x equals 0, x smaller than, let's do a width of 5 and x plus plus, for var y equals 0, y smaller than 10, y plus plus. And then we can say game add slot at x and y. And now we need to specify some sort of object that represents the slot. And now what's that object going to be? Well, all it really needs is, at this point of the game, all it needs to be is a texture. The way I can represent that is there's a few ways I can represent that. Let's go with a enumeration and an index. So I'm going to say slot type or rune slot type, and I'm going to do numeric, symbolic. And then I'm going to pass in a rune slot type. Let's do numeric, and then let's do, I don't know, our slot type index. Modulus 9. Okay, so we can now tell the game to add slots at X and Y coordinates. That seems like a sensible API. Next up, we need to add the runes to the gutter. So there's two gutters, and right now, the way I have this written, there are 50 slots, so we need a corresponding, or we need 25 runes on one side and 25 runes on the other side, and they have to match up with the slots in a way. Now, the reason I'm not really creating any sort of association between the slots and the runes themselves is because that's something that the server is going to be responsible for. The client is not going to be responsible for knowing if a particular rune can go into a particular slot. That leaves the flexibility, a lot of flexibility to the server, so that we could do things like maybe a special type of rune that could be placed in any slot or something like that down the line. So now we have to add a rune. To add a rune, all we'll really need to do is I'm going to change this from rune slot type to rune type, because we can reuse this for runes. So I'm thinking something like game add rune, and we can give it a gutter index of either left or right. So I can go ahead and add another enumeration called gutter location, left and right. And then I can say add rune gutter location left, rune type, numeric, and then an index of 0. So now I'm going to have to write code to automate this. So basically, I can just do slot type index equals 0, basically repeat this entire process, and then say instead of add slot, we can add runes. Actually, why don't we just do that in the same array? I'm a terrible person. I'm sorry. So add rune, so gutter location left, rune type numeric, and then I'm going to do the same slot type index. So I'm going to do rune index, and then we can combine that by doing that. And then, so now I can pass in rune index. And then as far as which slot or which gutter that we want to move to, I can just do if rune index or slot type index is smaller than 25, then put it in the gutter location left, otherwise put it in the gutter location right. And I can go ahead and pull out some constants. So constant int width equals 5, constant height equals 10, constant size equals width times height, and then I can replace this with width, replace this with width, replace that with height, and replace this with total size divided by 2. Okay, so now that we've initialized our players, we've initialized our slots and our runes, which very well might go into their own value objects at one point if the need arises to do that. At this point, we have a fully initialized game, so we can actually go ahead and start playing. So we can go ahead and say game.start. I mean, this seems fairly sensible to me. The next thing that I am already foreseeing something that's going to have to happen, because I want to develop this outside of the network capability that we've already established, we need a way to simulate receiving events from the server and receiving commands or sending commands to the server. And the easiest way to do that would probably be just to implement an interface. So under abstract, I'm going to create an interface called iGame something. I don't know. Think of an interface for this. Isn't the game variable a game object type? No. The game variable is a type of game board, which I should probably name this game board. I need a name for an interface that will be responsible for the game attempting to send user input back to the server, or in this case, back to nothing. So let's see what we can do with this. iGame mock input. Well, no, we're not mocking the input with the interface. Well, we are, but we're mocking the input with instantiation of the interface. So I could call this iGame view. I mean, that should be fine. And iGame view could do something like, could be like bool can place rune, and then we need a slot and we need a rune itself. So I'm thinking that it might be good to introduce the concept of an ID to our slots and our runes. So what I'm going to do is I am now going to add in the concept of a value object of both the slots and the runes. The reason I want to use an ID is because I want the server to be able to uniquely identify each slot and each rune, so it is responsible for knowing if a particular rune can be placed in a particular slot. So to do that, I'm going to introduce another namespace called value objects, and I'm going to spell that right. And then what am I going to do with it? I'm going to create a rune, which I guess I can just call it rune. And then it's going to have a uint ID. It's going to have a rune type and a uint rune type index. So for example, this will allow us to say, okay, we want a numeric rune at the second index, for example, and that should be the number 3. So we have an ID, a type, and a rune type index, and then I'm basically going to create another very similar value object called rune slot, which will essentially do the same thing. It's going to have a uint ID, rune type, rune type index. Now with this information, we will be able to uniquely identify every rune and every slot, and we will also be able to carry around the concept of a type and a type index so we can choose the appropriate texture to display the rune or the rune slot as. So now that I have that done, I'm going to refactor out my game test manager. So add slot is now going to say, instead of passing in that, it's going to say new rune slot. The ID, I'm just going to use slot type index for this, because that slot type index is incremented for every single rune that we create. The rune type, we're going to do numeric, and then rune index for the index. And it doesn't like this because there we go, now it does like it. Then I'm going to do the same thing with the rune itself. So I'm going to instantiate a new rune value object, passing in the ID of the slot type index. Now this is important because runes and rune slots are technically different objects. I can reuse their same IDs. So then the type, I'll just do numeric and then rune index. Now that I have this, I can now write my iGame view, and it'll have a boolean can place rune, and then I'll have a rune and a rune slot. And then we'll also have yeah, that's fine. Yeah, that's fine for now. It'll have to change it a little bit once we introduce networking, but not a whole lot. And it'll at least give us a good roadmap of what we need to do. So we need to tell our game about our listener. So what I'm going to do is I'm going to create a mock listener, mock game view that implements iView, or iGame view, sorry. And can place rune is simply going to say if rune dot type equals slot dot type and rune dot type index equals slot dot type index. So if the slot thing is the same thing as the rune thing, then return true. This is the simplest form of determining if we can place a rune. But keep in mind, the reason why I'm abstracting this logic is so that you could have maybe a special rune that can be placed in anything. So now we need to tell our game about our mock game view. So I'll do that. I'll say game.setView new mock game view. And there's a cat in my room, and I'm going to kick her out. Okay, so now we have a nice little roadmap of the different methods that we need to implement in order to make this API, well, work. So let's go ahead and do that. We need a game set view method that takes in an iGame view. We need an init players method that takes in a Derek Stevens. Just one second. And then what do we need? Let's do an IEnumerable of game sessions. IEnumerable of game session, and then a game session, R session. Yeah, that's fine. Then let's do an add slot, which takes in an X and a Y and a slot. And then adding a rune, which takes in a gutter location and a rune. And then we need a start method. And if for some reason ReSharper is not updating itself, okay, so just a quick note, if you guys ever see this happen, where ReSharper decides to not ever be able to resolve anything, there's a quick way to fix this. The easiest way to fix this anyway is to close out Visual Studio, track it down in Explorer, whatever the heck they're calling it these days, file viewer or something, can't remember what they renamed it to. There we go. Track it down in Explorer, find the resharper.unity C# project and just delete it. And that removes the cache. It'll redo the cache next time I load it up, and then those cannot resolve symbols will go away. It's kind of annoying, but you get used to it eventually. And then of course it takes forever to relaunch Visual Studio. And then we go back, and hey look, ReSharper decided to actually locate my symbols. So, again, this may or may not be optimal. I'm going to make this public. I like making these stupid magic methods public so ReSharper doesn't tell me to delete them. But, anyway, now we have a nice public API. It's very simple, and it will very much most likely grow over the course of development. But again, I haven't really done this particular project before, and this is how I generally approach things like this. And we'll see how it goes. Writing the smallest amount of code possible at first typically has been good to me. So now we have our game board, and we know after we add the slots, we know the dimensions of the game board. I do kind of want to send in my width and height of the game board during initialization. So what I'm going to do is I'm going to move my constants up here, and I'm going to change my init players to just an initialize method, which I'm going to quickly Google off screen so I don't misspell it. It's an A, doesn't it? I hate A's. Or no, was it E's that I couldn't do last time? So we have initialize that takes in our sessions, our session. I'm also going to have initialize take in our game view. And I'm going to have it take in the width and the height. And then it's wanting to create an overload. So I'll just delete the old overload in a second. So we have our game sessions, our iGame view, our width and our height. So what do we need to do? Well, we need to alias these out into different variables, private variables. So we need a IEnumerable of game session so we know who's playing. We need a private game session R session to know who is us. We need an iGameView, which this should not be called mock game view. And we need a width and int height. Yeah. Okay, so now that I have all that stuff, I'm just going to do game sessions equals game sessions, R session equals R session, game view equals game view, width equals width, and height equals height. And then we no longer need the setView method. So that seems pretty straightforward. Now I can add a quick check into the add slot to make sure that the x and y is within the correct bounds. I'm going to change this to be an unsigned integer x and an unsigned integer y, because I do not want negative values. Of course, that's going to cause this to fail because I need to change the parameters to booleans. So now I know they can't be 0, but I also want to make sure that they're within the bounds of the game. So if x is larger or equal to the width, or y is larger or equal to the height, then throw new argument exception, or slot must be placed in the game board. So that's a quick little sanity check, will save you a lot of time in debugging. So now we need to find a way to keep track of our slots. And what are our slots going to be? Well, I think the most sensible thing to do here would be to create a game object for both slots and runes so that they can handle their own sort of thing. But now we have to think about what makes the game board, which I'm starting to not like the name of that at all, because what we really have is we have two gutters, a board, and then on top of the board we have our slots, and then on top of our gutters we have our runes. So I kind of want to change this game board to just be called game. And then we'll also have a game board, which we already have a game go, don't we? Let's change our game go to game manager go, which I can't do because that'll conflict with game manager. Okay, let's change this to rune game. Well, this isn't the playable area. What I'm going to do on top of this is I'm going to create a few other game objects. The game objects that I need are a rune game object, which this is going to get so confusing. I need a rune game object, a rune game object, a rune slot game object, and a rune game board game object. Ugh, I hate my life. Let's just go with that. So we have our rune game object. These guys will be placed in the gutter. We have our rune slot game object. These guys will be placed on the board itself. And then we have our gutter game object, which will be the gutter. And then we have our game board game object, which slots will be placed under. So those are our game objects. Now that I have those in place, let's go back into my game go. No. My rune game go. I seriously need. When I'm on break, I'll figure out a better name for this. Okay, so what do we need to do? We need to create those game objects. So what we really need is we need a reference to our game board go called game board. We need a reference to our gutters, so I'm going to create a dictionary of gutter location slash gutter go. Gutters. We need a reference to... Actually, I'm not going to create a reference here to the runes or the rune slots. I'll put those in the gutters. So then, when we initialize this, I'll say game board equals game object factory dot create game board go game board. So there's a game board. I'm going to move this to the top just to be a little bit more consistent. Gutters is going to be a new instantiation of a dictionary that's going to have a gutter location left, which will be a game object factory dot create gutter go, and a and then a right. Now I'm going to go, because I need to reference both of these game objects, these gutters, I'm going to go ahead and alias these out into variables. So I'll have a left gutter variable and a right gutter. And then after I do all of this, I'm going to say transform child add create game object dot. Did I seriously forget? Oh, derp. I need to do, wow, that was embarrassing. Transform.parent equals transform. Left gutter dot transform dot parent equals transform. Right gutter dot transform dot parent equals transform. Okay, so what else do I need? I know that my left gutter and right gutter need to know what gutters they are. So I'm going to do left gutter dot initialize with gutter location dot left, and then I'm going to do right gutter dot initialize gutter location dot right, and then I'm going to implement their initialize method, which just sets a private gutter location location equals location. Okay, so that seems like it's going all right. We have our initialize method that sets up our basic hierarchy of the way this game is going to go. Next up, what we need to do is we need to start adding slots and adding runes. I'm going to delegate adding slots to the game board itself. The game board should have a reference to the actual rune game so that I can validate the width and the height. So what I can do here is I can say add another initialize method to this, call this rune game go game private rune game go game equals game. Then what I can do is I can turn width and height into properties. So Control-Shift-R, encapsulate field auto property inner. And now they're both properties. Because they're properties, I like my properties up there. That looks nicer. So now we have our width and our height exposed. So now under game board go, instead of doing underscore width, I can do game width or game height. Okay, so now we've delegated adding the slots to our game board, to our actual game board object. So that's a nicer design. Our rune game go won't get all ugly and gross. Now we need to delegate adding the rune. I'm going to delegate adding runes to the gutters. So I'm just going to do gutter at gutter location dot add rune. The next thing I want to do is I want to create a public boolean is playing. And when we initialize the game, it is playing is set to false. And then when we hit start, is game is set to true. This boolean is going to be used by our other children game objects to know if they should accept user input. Which means that I'm going to have to go ahead and add a reference to the Rune game object to our gutters, as well as our game board, and as well as our I created the initialize method, but I never invoked it. I absolutely hate how constructors, I'm not even going to go into it. I have solutions for that I built in the past, but let's just keep things relatively simple. Okay, then I'm going to pass in the game object into that, add parameter, jump back into gutter go, get a private rune game go, rune game go, and that should be fine. Okay, so we have our game objects all being created. We've successfully delegated adding slots and adding runes to the appropriate objects. We have a nice hierarchy of game objects going. We have the concept of whether the game has been started or not. So all in all, things are going pretty well. So at this point, it's going to have to be time to actually implement our gutters and our game boards and our runes and our slots. So let's go ahead and see if our hierarchy is even being properly instantiated. I'm going to go ahead and just hit run and see what happens. We get a game board, which has empty game object, and game board under it. So our runes are not being created yet, but that's because I never created them, so that's good to know. And I also want to go ahead and name my gutters. As well as provide a different name for instantiating the actual game. I'm going to just call this game. Okay, so now let's go ahead and now that I've delegated responsibility, I actually have to provide logic. So when I add a rune to a gutter is going to have a private list of rune goes called runes, which will be instantiated on the initialize method. Adding a rune, we'll say rune.add. I'll create the rune go by doing game object factory.create rune go, call it rune-blah, which will be rune.id, and then I'll add it to the list, and I'll do rune go transform parent equals transform. So that should instantiate the rune. I'll also have to initialize the rune. So I'm going to do rune go following the convention that I've established here with initialization. I'm going to pass in the rune value object into the rune game object so that the rune game object knows what texture to apply to it. Next up, we have to do essentially the same thing with our slots. The way I'm going to do this for now is I'm just going to implement a... Well, it depends on how we need to reference our slots. I don't think we ever need to reference our slots by X and Y. No, we don't. So I was going to create a multi-dimensional array, but I'm thinking about it, and I don't think we ever have to access slots by X and Y. So what I can do instead is just create a list of rune slot goes called rune slots, instantiate it on initialize, and then after we validated the X and the Y coordinates, I can say rune slots.add. I need to actually create the rune slot go, which is going to be game object factory.create rune slot go. I'm going to say rune slot-id, which will be rune slot.id. Then I'll do, again, following the convention, I'll do rune slot go.initialize. I'm going to keep it the responsibility of the rune slot go to position itself. So I'll pass in the X and Y as well as the rune slot. And then I'll add the rune slot go to this. And then I'll initialize it X, Y, slot. Which will just say private int X, Y. Nah, I don't like that. Private int, private rune slot. X equals X, Y equals Y. These are ints, these should be uints. slot equals slot. And did I give the same treatment to my rune go? No. I'll go ahead and say private rune equals rune. Okay, so we got this far, so let's go back into Unity and see if our game object hierarchy is being appropriately instantiated. And as we can see, they are not. Our rune slots are not being added to the parent transform of the game board. So let's go back into my game board game object and then do that. So rune slot go.transform.parent equals transform. Jump back into Unity, hit play. Okay, so we have a game board. Game has a game board, a left gutter, and a right gutter. Game board has all of my rune slots in them. Left gutter has the runes 1 through 24, and right gutter has the runes 25 through 50. Which I don't like. Give me a sec. I told you I'd fail with my math. Blah, 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 blah. There we go. 1 through 25, 26 through 50, whatever. No, that's right. I can't think. Maybe it's right. Doesn't matter. We need stuff to display on the screen now. Alright, so how's everyone doing? Who hasn't tuned me out yet? Okay, so now we have our game object hierarchy created. We have a basic public API for our game that will allow us to write code both in a test scene as well as hook up our networking in the future. And we have our different objects or different classes that are responsible for a very small amount of things. Now, what we need to do at this point is actually get some textures on the screen. The way I'm going to do this is I'm going to set up the camera as an orthographic camera, and I'm going to set its orthographic size to half of the height of the screen. Now what that'll do is, if you follow with all the crazy mathematics involved with that, it'll make it so 1 unit in Unity, no matter, because it's going to be an orthographic camera, it's not going to matter how far away the camera is, but 1 unit in Unity will become the size of 1 pixel displayed on the screen. However, to keep things fair, we're going to have to constrain the aspect ratio of the game, because we don't want 2 players who are running the game in 2 different sizes to have a different amount of runes or rune slots visible to them. One of the things about this game is that you have to scroll a lot. So we need to constrain the aspect ratio of the screen so that's fair, and then based off the grid size, how big the game board is, we can use that to determine how big each individual cell is, whether that be a rune or a rune slot. So let's go ahead and create something that will do that. For now, I'm going to leave the camera sort of stuff inside the Rune Game Go for now, because at the moment he's the only person that cares about the camera sort of things. I mean, I guess I could move that into a different class than just expose it through Rune Game Go. So I'll do that. I'm going to create a class called Screen Configuration. And now what Screen Configuration is responsible for doing is performing those calculations as well as actually setting the orthographic camera or the camera to be appropriately sized and set to an orthographic camera. So what I'm going to have a constructor that's going to take in a uint of the grid width. So the grid width is going to count how many cells I want on the width of the screen. And now what I can do is I can do some different things. I'm going to go ahead and add some public properties, such as a vector2 of resolution. so we can easily grab our resolution out of our screen configuration. I can go ahead and do a vector 2 of grid size, which will be calculated based off the resolution and the grid width. I'm going to have a vector 2 of grid cell size, which is going to be the height and width of every cell that's in the grid. And then I do need what's something called a height white space, and that's just a name I'm pulling over from something I did before. Basically, I want the grid to be sort of centered, if that makes sense. And to do that, there's going to be some room left over depending on the resolution and size of the window. And I need to keep track of that in order to do the right sort of mathematics. So we have our grid width. The first thing that we need to do is set our resolution. So our resolution is going to be a new vector 2 of screen.width and screen.height. So that sets our resolution. The next thing is we need our cell size, how wide each cell is going to be. That's simply going to be resolution.x divided by grid width. So that one should be very straightforward. We take however wide the screen is, we chop it up by how many items that we want. The next thing we need is we can now set our grid size to a new vector 2. We can pass in our grid width, and we can pass in, now this is going to be a little bit fun. We need math floor of screen height divided by cell size x. So that will calculate our grid size. Now we need our grid cell size, which is going to be a new vector 2 passing in our cell size x as well as our, cell size x as well as our cell size x, because the grid has squares. They're not rectangles. So that makes the computation a little bit easier. The next thing is I'm going to calculate the height white space by taking the resolution.y and subtracting the grid size.y multiplied by the grid cell size.y. So how much space left over is there if we wanted to center things? And I am being a little bit inconsistent here. Why am I using resolution y here and screen height there? I'm going to change that. Use resolution y. Finally, I'm going to set up the camera. So the camera .main .orthographic size, or first I'm going to set it to orthographic. Then I'm going to do camera main orthographic size, and I'm going to set it to resolution.y divided by 2. Keep in mind when you do this, that makes 1 unit of unity equal to 1 pixel, which is very handy and is makes all the math a lot easier, especially based off these properties that I've already established. Next up, I'm going to position the camera in such a way that what's going to happen is the position of 0x and 0y should be, or the origin, should be at the top left of the screen. So to do that, I just set it to resolution x divided by 2 negative resolution y divided by 2, and then I'm going to do negative 200 for its z position. That'll give us 200 levels of z indices to place things over each other. So now we have the camera pointing in such a way that 1 unit, blah, 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 you just heard me say that. So to test that, let's go ahead and jump into my Rune game Go. I'm just going to go ahead and I'm going to create a box. This is just a quick test. Create primitive type. Let's create a cube. I'm going to set his scale, his transform.local scale. I'm going to set it to, let's make him 32 pixels by 32 pixels by 1. Then I'm going to set his position to, let's set him to 5 by 5 or 10 by 10. So it should be at the top left of the screen with a little bit of space. And of course, I actually have to instantiate my screen configuration as well in order for those things to take effect. I'm going to expose that in the form of a public screen configuration screen property. And then on the first line of initialize, I'm going to say screen equals new screen configuration, passing in the width of the grid, which I'm going to set to a UN. So let's see if my math failed or not. Hold on, who are you complaining about? There we go. Better? There we go. Okay, so hit play, and what do we see? We see a cube, but he is not quite where we want him to be. Oh, I believe the pivot is in the middle of it, so I actually have to set him to 42 by 42, I believe. Okay, where'd my cube go? There's my cube. Now where'd my camera go? My camera is right there. And my cube is plainly out of... Okay, let's see where you're messing up here. So if I go into game and I move his position down, negative, that doesn't do anything. If I move his Y, there he is. So a position of 0 causes him to be half visible, which is what I wanted. A position of Y of 0 should be, so we should see a quarter of him right now. Now as I move Y into 32, I see what I'm doing wrong. Yep, so if I want him to be fully visible, he has to be at 16, negative 16. I did slightly mess up the math a little bit here with my camera position. Oh yeah, okay, so now I'm remembering why I moved it to the bottom here. 0, 0 is going to cause the... Let's see here. Yeah. Let's not make this negative, because that's just going to cause confusion. Okay, so 0, 0 is now at the bottom left-hand side, left-hand corner of the screen. So now by placing him at 42 by 42, he should be, that's 16, 16 plus 10, which is 26. He should be 26 pixels off the ground, and he should be 32 pixels wide. And that looks about right. So I'm going to leave it at that. Now, keep in mind that this screen configuration is incredibly important, because everything that we now do is now incredibly dependent on the way that we set up the camera and the way that we're calculating the sizes. Let's see if I can. Let's see if my other things get set right. If I do a screen, let's say I want him to be the size of a grid cell size X and a screen grid cell size Y, and then let's say I want to place him at cell size X times 2 and cell size Y times 2. And let's take a look at our grid and see how that's how those calculations are going. So it looks like what we have here is a width of 5 grid. So that's about 1, 2, 3, 4, Wow. Position, scale. Okay, so we'll tweak that a little bit more once we get to the game board itself, because then at that I was just considering just instantiating a bunch of or a bunch of those blocks and making it so that they all fill up the game board, so I can see how big my grid is. But I realized we can essentially do that if we just go into the rune slot go and go ahead and make this actually functional and have it apply texture, and we'll see where we are. So yeah, it's been about an hour. I'm going to go ahead and step outside real fast, and I'll see you guys in a moment. And we're back. So now that I've actually had some time to gather my thoughts, what's going on in as far as the size of the grid, I was sitting there looking at it and I was kind of confused for a second because I lost a bit of perspective of what actually is going to go on. Basically, what I'm going to have is I'm going to have a gutter on the left-hand side and a gutter on the right-hand side, and then a game board in the middle. Now, the game board size is going to be defined by the parameters that we passed into the rune game board. We passed in the width and the height. These determine the game board size. However, when I pass that width into the screen configuration, what this is this determines the global grid that applies to both the gutters and the game board. So what I need to do actually is I need to actually increase the width by 2 when I instantiate the screen configuration. That's kind of why I was looking at that thing that I created a moment ago, that game object, and I was like, oh, that looks a little bit bigger than what I thought it would be. Well, yeah, it was bigger because I forgot to take into account the gutters. So now that that's in place, let's go ahead and get some sprite action going. So there's a few ways of doing this. The way I'm going to do this is I'm going to go ahead and I'm going to create, inside of my game object factory, I'm going to have a public static game object, or how am I going to do this? I'm going to create a game object helpers method or class, game object helpers, public static class, game object helpers, and then I'm going to have a public static void apply texture. Or how about create sprite? Create sprite is going to take in an abstract class called iTextureAssigner, and we'll see why I created this this interface momentarily. Because what I want to do is I want to say assign for both it's going to accept a mesh renderer and a mesh filter. So now that we have our iTextureAssigner, my GameObjectHelpers method is going to take in a game object as well as an iTextureAssigner. And what it's going to do is it's going to take this game object, it's going to create a mesh, and that mesh is simply going to be a square, and then it will use the texture assigner to assign a texture to it. And the reason that I have an interface for the texture assigner is that I want to be able to support passing in just normal textures, but I also want to be able to support sprite sheets. So I'm envisioning 2 texture assigners, one for just straight up images and one for a sprite sheet where you give it the reference to the sprite sheet's name, the sprite's width, the sprite's height, and then the sprite index that you want to pull from. So that'll allow us to keep things relatively straightforward. Now create sprite, what this guy's going to do is he's going to basically just create a like I said, a normal square. And I'm trying to think of what the best way... See, this is going to be important because I want the square that it creates to be in such a way that if I were to place something at 0, 0, that it would be at the bottom left of the screen. That means that the pivot of this mesh is going to be at the lower left-hand side of it. So let's see what we can do with that. Well, first, I need to instantiate a filter. So I'm going to say filter equals game object, add component, mesh filter. And I also need a renderer. game object, add component, mesh render. Now I need to create my vertices. This is going to be fun. This is the part that I've been afraid of. Okay, so what's my vertices going to look like? Well, we need a vector 3. The first vertice, let me see, we need to wind it clockwise. So let's do a little diagram here. So I want the first vertice to be here, and then the second vertice to be here, and then the third vertice to be here, and then the fourth vertice to be here. I believe that's what I want. So that means the first is going to be at 0, 0. The next is going to be at 0 and x, 1 and y. Shut up. The next one's going to be at 0, 1. The next one's going to be 1, 1. And the final one is going to be at 1, 0. So those are our verts. Now we need to create a mesh. I'm going to set the filter mesh to this mesh. I'm going to set the vertices to my verts. This is going to be fun. Next, I need to pass in an index buffer for my triangles. So I need 2 triangles. The first triangle is going to be 0, 1, and 2. So I can do 0, 1, and 2. The second triangle is going to be 2, 3, 0, I believe. Don't hate me if this doesn't work. Finally, I need to tell it to calculate its normals, which I'm not going to do manually. I'm just going to tell it to do it for me. Then I'm going to assign, so I'm going to use texture assigner dot assign mesh and filter. And by mesh and filter, I actually meant renderer and filter. Okay, so by doing this, I should be able to turn any game object into a sprite, as long as I go ahead and implement the appropriate iTexture assigners. So the first texture assigner that I'm going to do is going to be a very basic one. All it's going to do is assume that we're going to be filling up the entirety of this mesh with the entirety of the texture. So that makes UV calculation very easy. So I'm going to create a basic texture assigner, which implements iTexture assigner. And what he's going to do is he's going to have a constructor that takes in a string texture resource. So what texture do we want to load? I'm going to be doing all the texture loading within code itself. I'm not going to be using Unity game object parameters for that. That's just going to make it a lot easier for me to write out all the ridiculous amounts of runes and associations to different textures that we need to do. So, what do we need to do here? The first thing is, in a constructor, you know what I'm going to do? I'm going to create a private read-only static dictionary of string and texture called texture cache. I don't know if we'll actually ever do this, but I don't want to reload textures. Then I want to do texture output if texture cache try get value texture resource output. Then what we can do is just say texture equals output. Otherwise, we need to say texture cache at texture resource equals output equals cast a texture resources dot load, then give it the path, which is going to be texture resource. We need to force refactoring, otherwise the precipitation pressure move. Well, yeah, things will be made a little bit nicer soon. Okay, so I'll create my read-only texture. So now we have a basic texture assigner which caches textures and takes in a string resource name and gets a texture out of it. So now how do we assign it? Well, all we gotta do really is tell the renderer to use material.mainTexture equals texture. Then we will be probably setting a different shader here shortly, but for now I want to keep things more simple. Then for our mesh filter, we need to set our mesh as UVs. Okay, so the UVs are going to correspond basically to the way that we've set up the way that we've been deciding to build our quads. So if I go back and grab my little comment here, which is kind of embarrassing that I have to write it in the first place to get this stuff to work, or to remember how to get this stuff to work, I'll just paste that down here, and I'll go ahead and assign the UV coordinates are basically just going to be the same thing. So the texture will fill the entire mesh. So the first one I'm going to do is, oh, what am I doing? I can just derp. There we go. And these need to be vector 2s. And then I'll just remove that comment because it's kind of embarrassing having it there. Okay, so now we have a basic texture assigner that sets the UVs appropriately. So now that we have that done, what I'm going to go ahead and do is I'm going to go ahead and jump into my gutter game object, and when he's initialized, I want to do game object helpers.createSprite, passing in this and a new basic texture assigner. Now, let's go ahead and import some assets. I'm going to go ahead and I'm going to create a new folder called textures, and under textures I'm going to create another folder called resources. Then under resources I'm going to track down where I put those things, put them somewhere, and I need my gutter left background and my gutter right background. So I have my gutter left and my gutter right. So that looks good. I'm going to leave this, I'm just going to leave everything the way it is. So now that I have that, I can come in here and I can say, if we are looking at a left gutter, apply the gutter left BG. If we are looking at the right gutter, do gutter right BG. And then instead of this, I need to pass in game object. Okay, so now we have a sprite created. The last thing that we need to do is position our gutter and scale our gutter. So to position it, I'm going to go ahead and say transform.position equals new vector 3. Both of the y's are going to be at 0, but the x's are going to be, for the left one, it's going to be at 0. So if location equals left, it's going to be at 0. If the location is right, then it's going to be the size of the gutter subtracted by the resolution of the screen. Now, what's the width of a gutter? The width is determined by a single grid cell. So what I can do is I can say rune game screen dot grid cell size dot y, and then have that subtracted by rune game screen resolution dot x, and by y I meant x, by the way. There we go. Even though the grid cell size is the same in x and y, I'm still referencing the appropriate things. Now we need to set its scale. So for now, what I'm going to do is I'm going to set its scale to a new vector 3 of rune game screen resolution, rune game screen grid cell size x and rune game screen grid cells or resolution y. Just running through this in my head real fast. Yeah, I think that should work. Okay, now let's go ahead and fire up Unity and see what happens. Hey, look at that. Come on, admit it, guys. You didn't think this was going to work on the first try, did you? However, they are black. Now, okay, so the winding order is correct, which is good. But they're black, which could either be because of the material used or because of the UVs being incorrect. So let me put in a light, point light, and see what happens. Absolutely nothing happens. Okay, so let's see what we can do here. I'm pretty sure it's going to have to do with the way the materials is, the default material that I'm setting is accepting the wrong shader that is trying to take lighting into account. I think that's what's wrong with it. So what I'm going to do is I'm going to go ahead and create a material that I can go ahead and assign to all my sprites, and I do want it to be let's just go ahead and see what happens. Let's create a new folder called materials, and let's create a resources folder, and let's create a material, and let's call this sprite material, and let's give it a shader of unlit texture. That seems sensible, I suppose. So what I'm going to go ahead and do is I'm going to jump out of this, go back into my game object. No, I'm going to set the shader. Yeah, I'm going to set the shader in the game object helpers. I'm going to go ahead and say render material equals, or dot shader, or how about just material? I can just do that, and then do material resources load sprite material. And then assign that. And then I also render material. Oh, hold on. Wow, I'm doing this all wrong. The render material is, I need a new one every time. I wonder if that set the main texture. I'm pretty sure I already do that in my assign. Yeah, material main texture equals texture. Hey, and look at that. So those are my gutters. And they're scaled awfully right now, but that could probably be fixed by setting the appropriate aspect ratio on the screen. So, yeah, if we jump down to game, let's do a 4:3 and hit run, and that looks a lot better. Looks like we are off by 1 pixel there. Let's figure out what's going on with that. If I look at this guy, the gutter left, he is being set to a scale of quite a bit. He is being set to 0, so I wonder why. Okay, so this is just some nasty floating point grossness. Let's just leave that there for now. Whatever. Okay, so those are our awesome gutters. Now, the next thing that we need to do is let's go ahead and create our rune slots. Now the way that this, if I recall, let me go ahead and look at my textures that I have here already. I believe what happened was we have our rune number slots. Yeah, we have our rune number slots and our rune symbol slots and our tile slot background. Okay, so we applied the tile slot background to every single rune, and then on top of it, we put the rune slot in, I believe. Because if I look at the actual runes, no, not you. Sorry guys, just give me 1 second. Just going through. So there's a game background. So I believe the game background gets applied to the game board, and then our tile slot backgrounds go underneath all of our rune slots, and then on top of that we then apply our runes. So those are the slots, and then give me 1 second while I track down one resource that is eluding me. Okay, we have buttons and backgrounds. What does this do? Oh, I think that's the background that should be applied to everything. We have our UI elements, we have our buttons, we have dialogue headers, we have a frame, game background, group background. That's for the UI stuff. We have our headers, we have more UI stuff, and then we have our rune numbers.tiff. Okay. So why did you open in that? I don't want to use the stupid Metro picture viewer thing that opens up as a full screen. Like, what a waste of space. Open the photo viewer. There we have it. So, okay, so those are the runes that are going to go on the gutter. Then, this is going to go underneath every single slot. And then on top of every single slot, one of these is going to go on top of that. And then underneath all of that, our game background is going to be, is it this guy? Or this guy? No, our game background is going to be applied. Alright, so let's go ahead and get this going. I'm going to go ahead and import my resources and rename them so Zach created the textures. So I need my background, which is going to be the background of the game. I need my rune numbers dropped, rune symbols dropped. Then I need my tile slot background and tile highlights. Oops. Okay, so those are the textures I need. And at the end of this, I'll go ahead and zip all these up and put them somewhere that you guys can get to. So let's start off with background. Actually, let's not start off the background. I'm going to leave that till last, just because that cornflower blue, you might really hate it, and I kind of do too, but it is a very good debugging tool. So let's go ahead and start off by placing our tile slot backgrounds where all of our rune slots are. So that means that our game board, oh, I actually lied. I'm going to do the background first. The reason I'm going to do that is because I want to position the game board now. So how do we position the game board? Well, we need to figure out we know that we have a grid, and then we have to subtract 2 to it, and that's how much space is left for our game board. Now we know the game board's width and height is going to be, so let's start with that. So transform.scale equals new vector 3. The width of the game board is going to be screen.gridcellsize.x multiplied by game.width. The height of the game board is going to be game screen grid says blah blah dot y multiplied by game height, and then with a scale of 1. So that's going to be the width of the game board. Now we need to figure out where we need to place it. And let's start off with placing it somewhere. I'm going to start off, because probably next week we're going to go through actually panning and scrolling the board, and at that point we're going to have to calculate the maximum and minimum bounds of where the game board can move. So let's start off with putting the game board at transform dot position equals new vector 3. Let's start off with putting him at game screen grid cell size x. That will push him past the first gutter, and then a y of 0, that'll make him entirely visible, and then a z of 1. Then let's do game object helpers dot create sprite game object of new basic texture assigner background. So if I did everything right, which apparently I didn't. Where are you? You are tiny. There you are. Huh. Doesn't like the scale. Let's see here. Game.width, is that 0? Maybe. It could be. Let's go into my game go. Sorry, my Rune game go. And make sure that, yep, we don't set the width or the height until we initialize. I'm going to move all of this initialization code underneath all of our assignment logic to make sure that everything is properly set. Hey, look at that. We have a game board that is pretty much exactly where it needs to be. And it's positioned correctly, and you see how it does stretch up. Keep in mind what we're going to be doing later is we're going to be having it to where we can scroll the game board. I kind of want the game board to start off like this though, already scroll down to its minimum bound. So to calculate that, I can just go ahead and give it a y of, instead of a y of 0, I need to give it a y of negative resolution y negative, wait a sec. I need to give it a y about negative 811. So how do I get to 811? Well, I can take the entire height of the game board and I can subtract that by the resolution y, or the other way around, resolution y minus the game height of the board, and then negated. Because I want to push it down. Let's worry about this next week when we get scrolling and panning, because I don't want to get my mind in that mindset and then have to end the video. So let's go ahead and place our rune backgrounds. So our slots are going to be positioned. They're going to position themselves, so which means I do need to pass in the game board into the initialize of the rune slot. So if I go into game board go, on the add slot method, I need to go into the initialize invocation and pass in a reference not to this, but to the rune slots. No. What am I doing? To game. There we go. So now that we have game in our... Did I seriously undo that? There we go. Now we have our game, and I can go ahead and say private rune game go game game equals game. Now we can calculate where this should be. Now keep in mind, because I did intentionally parent my game board to the rune slots, I just need to think of coordinates relatively to the game board itself, which means 0, 0 is going to be at the top left of the game board. Which means my transform, well, let's do my scale first. Transform.localScale is going to be new vector 3 of game, screen, grid cell size x, game, screen, grid cell size y, 1. So that's my scale. And then my position is going to be a new vector 3 of, we need x multiplied by game, screen, grid cell size x, y multiplied by game, screen, grid set size, blah, and then a z of 1. And then I'm going to apply, I'm going to use my game object helpers to create a sprite. Now this is where I need to write a texture assigner that is capable of calculating the UV coordinates of a sprite. Because notice how I have a bunch of sprite sheets here that I'm using. Ooh, not for the tile slot background. So I can cheat for that. I can say game object helpers dot create sprite, passing in game object and a new basic texture assigner passing in title slot background. So now when I run this, what do we have going on here? We have a Z index problem and a transform problem, and I know how to fix both of those. Yep. Okay, so for the Z index, these guys are going to be placed at Z of 2, and then their position is not going to be position, it's going to be local position. So that will translate it relative to the game board. And I really thought that was going to work. Am I going backwards? Oh yeah, I'm going backwards. Hold on. I need to give this a -2 Z index because I placed the camera behind the scene. And we're getting a lot closer. So we have all of these guys, all of our tile backgrounds, but they're not being appropriately translated. And it seems that that is a consequence of something. As a consequence of the game board, he is not being positioned properly in the X coordinate. No, he is. I was looking at rotation. Derp. So that is working, but for some reason we're not getting... Oh, you know what? I initialize it before I set the parent transform. Okay, so let's set the parent transform of the rune slot game object before I initialize it, and I forgot how much Unity hated me. Wow, those are some big rune slots there. Okay, so what are we dealing with here? We're dealing with failures of mathematics on my part. The scale is 1, 2, 4, but I'm pretty sure I set the local scale, didn't I? RuneSlinger Go, I set the local scale, which is the scale that I want to set. Do I have to set the scale before I set the transform? I didn't think I had to do that. Ooh, did I set the scale of the game board before I initialized it? Yeah, I did. And I set his position appropriately. Let's do a quick test. Let's set the scale before we set the transform. Focus. Hold on, I lost everything. Okay, there's our main camera, and there is a ridiculously sized... No, that's not ridiculously sized, that's appropriately sized. Okay, so we have our game board, we have all of our rune slots, and it looks like their Y is being set... Get out of ISO. Their Y is being set stupidly. Local scale. Local position. Tell me. Why am I failing at this? There we go. Well, now we're back to square one, where it's not respecting the position correctly. Because if I just do position, then the same thing happens. No, not the same thing happens. Or, hold on. In the spirit of not wasting people's time, I'm going to go ahead and pause the video while I figure this out. Alright, and we're back. What I ended up doing here is kind of a dodgy workaround, sort of. What I'm doing is I'm leaving the game board at the origin. Then I'm adding in my rune slots by setting their position to the absolute, or to the relative position of the game board. Then I'm setting their parent to the game board itself. However, I'm not moving the game board into its final position until the game has been started. So I added this method called start, which is invoked from the Rune Game Go start. As you see right there, I say game board to start. So I'm going to be taking a look at stuff outside of this just to get a better handle on what was exactly going on there and the differences between different environments that I played with in the past. But as you can see right now, it does indeed work, and I can move the game board up and down by modifying his Y parameter. Also, if I jump back into my test, which is under U, test this, and if I set the game board width to like 20, for example, what we'll see is 20 things. So as you see, everything gets scaled appropriately depending on how many slots I request there to be. However, I am going to probably be decoupling this down the road. What I want to be able to do is have the game board extend both vertically and horizontally out of the bounds of the gutters. So I'll be decoupling the game board size from the size of the actual window. But I'll still be using all the computations we've already established in order to place things like the gutter. So yeah, unless there's any more questions, I think that about wraps everything up. See you guys after, or in a week. Bye.